What is mathematics, what is science, what is technology, and what do we mean by engineering? I also had the opportunity to interview many people who have applied for post of assistant professor or associate professor in colleges and universities. And I have realized that even when the people do have the degree of BTech or MTech or MSc, they do not understand what is the difference, because if we have some classification, science, technology, engineering and mathematics, and how mathematics would be important in quantum technology, what is the role of science in quantum technologies, and what is the role of engineering, and similarly the technology itself is in the word, so you may think that technologies are involved in quantum technologies. But if the picture is not clear in your mind, now you can get information from sources and you can understand part of it and even can apply it. Sometimes partial information also make us capable of doing something, achieving something. So an idea from a new idea you can break even without understanding things in complete and total. But path-breaking research and innovation only take place when you have a clear-cut understanding. Those who have contributed significantly in the advancement of knowledge, they had the much clearer idea of what it is all about. So my first appeal to you, to every member of the Nexus, to all the students of DSEU, is to take the things seriously and in detailed manner. The basics and fundamentals should always be clear. The applied part should be the outcome of that, whatever. If you have much better understanding, fundamental or in-depth understanding of the concepts which are involved in solving a particular problem or in developing a solution, then you can become more productive. So what is the mathematics? So mathematics is an abstract science. It has nothing to do with the nature, and therefore it is also said that even if nature is not existence, universe is not in existence, mathematics can be conceived of. So mathematics doesn't depend upon nature. Point number one. Point number two, which I wish to communicate to you and which I have highlighted here, is that mathematics is constructed or invented. Mathematics in nature, for example, we have planets, we have not constructed. We generally attribute maybe sometimes to some divine power or God or somebody else may have constructed the universe. But mathematics is construction of by an intelligent species. It has nothing to do with any natural system, but it is constructed. And when you construct something, then how many possibilities are there? How many types of mathematics have already been constructed? How many new mathematics can be constructed? The first thing I shall realize that I can construct infinite mathematics in general, because there is no limit or no bound whenever you construct. What you have to do, you have to specify axioms, and generally most of the mathematics which are meaningful, useful in science, technology, engineering are those which are axiomatic mathematics. So we construct axioms. Axioms are kind of assumptions or statement which you think or which you believe or which define the structure of the mathematics and which you believe are true. And then mathematics has an interesting feature that something can be proved sometimes in mathematics, because whatever you call theorems, we generally believe theorems can be proved. In some cases you may find it difficult to prove it, but still we observe that there is no violation of in the mathematical analysis of that particular theorem. So it is valid. So this kind of scenario is the construction of mathematics. So once you understand this, what you have on mind is that whenever required, you should be ready to construct a new kind of mathematics. Mathematics will be required. So when we made a migration from classical to quantum physics, new kinds of mathematics. So when Newton came up with some theoretical idea, a new kind of mathematics he invented, and at the same time the particular kind of mathematics was invented by Lambridge. And so there was a dispute between Leibniz and Newton who invented calculus. But without calculus, Newtonian mechanics cannot be explained or understood by anyone. So you have learned calculus in the school and you know the calculus, but there was a time when calculus was not in existence. Very similar to there was a time when universe was not in existence and it emerged. So as the need arises, we construct mathematics and definitely the new mathematics which we construct will be more complex. But mathematics and mathematical analysis is compulsorily part of all other three streams: science, technology and engineering. So one must feel comfortable with mathematics. So earlier it was believed when I was a kid that the students who are not good in mathematics should opt for which course? So should opt for biology because it was thought that the biology is less mathematical in nature. Now it is not true. Already I have given you one hint that very soon the biology will be quantum biology. So now in a present time the biology cannot be understood and even the experiments in biology cannot be performed without involving sophisticated instruments, and sophisticated mathematics is therefore essential to understand the biological phenomenon also. So that's the one part that you should keep in mind, that you will have to learn new mathematics, and if you are not ready to, there are no shortcuts for the learning. Quantum technology is not like that a course on history of a Mughal period, where without even prior any knowledge who were before the Mughals, maybe you can learn something. It's not like that. You have to understand the mathematics, and mathematics may be complex also, but you have to. And a better exposure means if you have gone through and worked out certain examples just in the abstract mathematics, then only you can apply it efficiently in the problem which is on your mind. So that's the first love always should be the love for mathematics. That is my message in brief. And after your questions we can. So I have already said mathematics assumes it is generally believed cannot be questioned, but the person who is creating the mathematics questions the axioms. Maybe different axioms may provide a different kind of mathematical framework and things like that. So you should also feel this thing or believe in this particular statement that axioms should also be questioned. Maybe axioms are putting some restriction on the mathematics, and the problem which you have on mind requires a wider span of knowledge or a new kind of mathematics. So if you change the axioms, mathematics is also changed. So we have been doing calculations, and now a question which I am giving you as an exercise or assignment which you can write down in your notebook also, that how many type of calculuses are there. The question is what? The calculus which you have done in the school, differential and integral calculus. Almost everybody here present knows about differential and integral calculus. But my question is, how many type of calculuses have been invented? So definitely it is very easy to get the answer. You can pose the same question to ChatGPT or DeepSeek or Gemini or whichever AI tools you like, and you will get the list. But then you will have to apply. So there are different kinds of calculus. What is different? What is common? Why all these branches of mathematics are called calculus and so on. That is very important. After the mathematics, we could improve the design part, and in the middle edge, different kind of technologies could come into existence, new kinds of architecture and so on. So that was possible. I am not speaking on each and everything mentioned in my slide, remember. Now we come to the science. As you know that science, the starts from somebody may say Copernicus or Kepler or Galileo or Newton, so from their period. Now, when science in the present understanding and present form was being developed in the European world, then what was happening in India at that time? What politicians and teachers do that they teach you history in such a manner that there is no mention of science in history. So you don't know that when Galileo was working on making a telescope, who was doing what in the India at the same time? Was anybody here working on telescope? Maybe no. So who came and took interest, maybe inspired from some information which came to him? So you know that in Delhi also there is an observatory, Jantar Mantar, and which was established by the rulers of the city which I belong to, the Jaipur primarily, and Sawai Jai Singh was instrumental. And Sawai Jai Singh is the only scientist or scientifically oriented ruler of that period of time. So that you will realize that when Galileo was doing, when Newton was coming up with the calculus, people here were not serious in taking calculus, but were doing something else. So you have to check whether calculus was invented first or where Taj Mahal was made first. So this is another second question. This is also give you a clear cut picture of how so Taj Mahal बनाया पहले या calculus has come into existence first. So Lambage and Newton or Taj Mahal. So Taj Mahal you can very easily, because most of the people have a great liking for Taj Mahal because it is related to the biological phenomenon of love and people who like it, Saga and Taj Mahal. However, Taj Mahal should be remembered, as I generally said, I have earlier also said in this room also maybe, and that is that it should be remembered for the skill set which the artisans, the workers, the mysteries, whosoever was involved in making Taj Mahal were having, and the planners which were having the knowledge of architecture and each and everything. They were not having any formal degree from any institutions, but Taj Mahal was constructed, and maybe Pyramid was also constructed, even when there were no engineering college, no technical institution, but some kind of knowledge was existing, people were pursuing. Formal classification or structure of education was not there. So that's very important. So science, you understand what is science? Science is different from mathematics. Mathematics sometimes is all the science, but it's an abstract science because it has nothing to do. When we say science, science has something to do with the nature. So in the word definition of the science, simple definition which you may have learned in the school also, is science is systematic study of nature. Now what is nature? So nature is a set. Now you have to understand it in mathematical terms, then only you can understand. Nature is a set. It is a set of what? It is a set of natural system. And then what is natural system? And what is a system? So first thing, system, by system we mean an object or set of objects of our interest. So like in Newtonian dynamics, particle is a system. Now particles do not exist in the nature because Newton has conceived particle as a point size object. Nothing of point size exists in the nature. Point size is a concept in mathematics, what we call point, what is the meaning of a replacement that you have to understand from mathematical point of view. But natural systems are those systems which are either exist or observable in the universe or nature, or which may be observable in future in the nature, or sometimes which are just conceived to understand something which is available in the nature. So like I am telling you, Newtonian particle is not as something which exists in the nature, but Newtonian particle helps us understanding the dynamics of the Newtonian particle, helps us understanding the dynamics of rigid body, or dynamics of a ball, or dynamics of a football, or even so on. You can throw anything and dynamics of that object can be understood only in terms of dynamics of particle in the Newtonian mechanics theoretical framework. So, particle is not observable as such, but is a system in science. And few years back, people in 1960s proposed a particle, so-called particle, which is not Newtonian particle, but which is now known as God particle. So God particle was proposed in 1964 or so, but it was observed much later. And in 21st century, it was proposed in 20th century. So many years after it, we could observe. So something which you require to explain the dynamics of the nature, you can propose, that would also consider part of the natural system. So science is all about natural system, and we do believe that what is the business of science is to describe those systems and describe the change in the system. दो तरह के description होते हैं. Generally, one description is about the, say, when you give something to a poet, then he would describe the beauty of that. आप जानते हैं कवि जो होते हैं कविता लिखते हैं सौंदर्य शास्त्र के ऊपर. आपने गुलाब का फूल दिया तो वो कोई कविता गुलाब के फूल पे लिख सकते हैं, और आप अगर उनको पसंद आ गए तो वो आपके ऊपर कविता लिख सकते हैं कि आपका चेहरा गुलाब की तरह है. अब आपका चेहरा आप जानते हैं केमिकल फिजिकल प्रॉपर्टीज doesn't match with the chemical and physical properties of the flower rose, but still it appeals to you. So one thing is to describe the state, another thing is to describe the change in the state. So there is only two businesses involved. Every natural system, scientific system, and we will be constructing new scientific system also. So this question will be always open. What we wish to do in science? We wish to describe the state of the system. And we also wish to describe the changes which will happen, because we have realized that the change is the common law. System would not remain as such. System would change. Even sun would die. Like you may or may not die, because now kind of technologies which we are involving, quantum technologies, maybe it would be very difficult to die, and maybe some of you may survive for larger duration, thousands of years, and few of you may survive for 200 years plus. But that kind of scenario could be very soon in common thing, that people could live much larger. Longevity would get enhanced because of, again, quantum technologies. One of the output of quantum technologies would be enhancing longevity of human being as a biological species. And maybe people do have a desire to become godlike or Amar. So as you may have realized that in the field of quantum intelligence, the divine intelligence is also considered as a possibility. The super intelligence may survive for an infinite period of time also. So that kind of ideas are being explored by scientists working in this particular discipline. So that's about science. You have said something, you can further explore it. What is the basic meaning of science, and whatever you would like to do in the future in quantum technologies, what is the science part, what is the mathematics part, and third part, because today it is very important, engineering part. Engineering is generally done on devices and elements, but general definition of engineering you are familiar with, it is given here, and why calculus is not called engineering and is called mathematics. That is also a question one should answer. The calculus is not engineering, but civil engineering is an engineering. So with this definition, how can I say engineering? So what would be, I would be calling as engineering, which is quantum in fundamental nature. So quantum engineering would be what? Quantum technology is the word. Quantum engineering, quantum science, and mathematics, which is useful in quantum mechanics. So remember, quantum technology is not something which should be addressed in one single way as a technological point of view. Unless you know the necessary mathematics necessary science related to it as well as the necessary engineering which would be required. Now, maybe engineering also involved a skill. At what scale we can do the engineering? That question also I will take it up in future also, and in this talk also at later stage. But as it has been said that in science, the important questions are why, what, how it happened, and when, what will happen, and these kinds of questions science answers. But engineers take pride because they think that they can change this world, or they can make the things work in the betterment direction. Science may be pursued with a search for knowledge only. There are two aspects that um, about knowledge. Knowledge for the sake of knowledge. Most of the philosophers are only concerned about their approach, knowledge for the sake of knowledge. But scientists, technologists, engineers are not concerned only about knowledge for the sake of knowledge. They take deeper interest and make applications out of it so that it can change the world or make a scenario better. So how can we solve the problems? Some of the problems are engineering problems, some of the problems are mathematical problems, some of the problems are scientific problems. Every time you look at the problem, maybe you have to first address it into that particular detail. That to solve this problem, what kind of mathematical knowledge is required, what kind of scientific knowledge is required, what kind of engineering techniques I must know, and then how the technology can be developed, which is something much bigger because they are, as I have said, that now in the STEM, science, technology, engineering, mathematics. So after science, the word technology comes in existence. But in real, the advancement of the knowledge, the science and engineering come prior to the technology of the present time. So technology also you understand. So why it is called wave technologies, or why not it is called wave engineering, or why I should call it networking engineering, or it's a technology. That question should be clear in your mind. However, this is just a academic question. But this academic question is important because there may be certain engineering aspects involved and there may not be any engineering aspect involved in doing something. So suppose I wish to develop a website and without using any tool, let's say right from the scratch HTML, HTTP, as Tim Berners-Lee invented, we could write and publish the website. So why it is called technology? Why it is not called engineering? Whereas if I have to make a washing machine, it is called engineering. The washing machine is engineering. Publishing a website is not primarily engineering. There is some kind of engineering involved in the background. But if you are just a web developer, you are using some things and approaches. So definitely application of scientific knowledge for practical purpose, especially with some application in mind, some welfare in mind, some purpose in mind, is called technology. Technology is purpose driven. Science is curiosity driven. So there is a difference. If you wish to pursue science, you must have curiosity. If you do not have curiosity, you cannot. And if you wish to pursue technology, you must have some purpose on mind. Unless you identify the purpose, you cannot get the necessary exposure to the kind of technology that is related to your purpose and you cannot achieve your goals. So it's very important. So in my understanding, that's why I am emphasizing. So how can we create it? What kind of technology, techniques, tools, methods, knowledge is accessible? Everything one has to do. So technology is heavily dependent upon all the other three branches. Mathematics, I have said, is abstract. Advanced because no existence of the nature is required. So if you are a pure mathematician, maybe you are not bothered about any purpose. You are just introducing new and newer kinds of mathematics. Now, How I already said, but I'll just give one third example. E, you know that 2 into 3 is equals to 3 into 2 in mathematics. Okay? What this property is called? 2 into 3 is equals to 3 into 2. So 2 and 3, as you know here, are say real numbers or integers or maybe whole number only, and 2 into 3 equals to 3 into 2. You call commutative property of the product operation. Product is an operation. This operation is defined on the members of a set, which may be the set of integer or real number or जो भी आप consider करें, and this is the commutative property. So one object is a number which you have done. There are n number of different types of numbers. So you can also draw on AI tools how many different types of number have been defined. So 2 into 3 is equals to 3 into 2. Now I say A into B is equals to minus B into A, and A and B are number. What are these numbers called? So A into B is equals to minus B into A. So order is now important because A into B, if you multiply in that order, A first and multiplication can be and minus B into A. So as I have said earlier, mathematics is constructed. This mathematics has not been also constructed. It is very useful in understanding certain physics phenomena, the advanced knowledge of the physics, and maybe in future you would also have to understand it. And these types of number are called Grassmannian number. So one new thing which I have told you, which you were not knowing before coming into, that there are numbers which are not commutative. Or the product operation defined for those numbers is not commutative. If A into B is equal to minus B into A, what will be A square? What will be A square? So A square would be 0. Because it cannot. Because A into A should also be equal to minus A into A. So in case of 0 plus 0 and minus 0 are same. But in the other numbers, what you say that plus 1 is different, minus 1, plus 1 is greater than minus 1 is lesser than plus 1, and so on. So these are the numbers where you cannot have a polynomial with a degree higher than 2, higher or equal to 2. Only thing in the polynomial you can have that power 0 or power 1. So those kind of mathematics have been constructed, and now I am just giving you an idea just to increase your curiosity in mathematics, that any new endeavor would require learning about new kinds of mathematics. Whatever mathematics you have learned in school and colleges is very childish mathematics as far as the kind of the mathematical knowledge which exists as of today and which is useful also in modern technology. So that was the message for you. So again, coming now, brief history of change. We are presently living in the information age, and whatever quantum technologies will be making much significance in the later periods which have been defined as symbiotic age, autonomy age, or tech singularity, not very far. And the Ray Kurzweil has written the book Singularity is Near, and then he has written another book few years back, Singularity is Near. If you get time, then read that particular book. And also read the book written by Yuval Noah Harari, and which has the title Nexus, which is the title of your society. So same title, Yuval Noah Harari has published very recently, 1 or 2 years back, a book titled Nexus. It may have some more words attached to it, but primarily the Nexus is very catchy term and catchy word. That's why you have chosen it as the name of your society. But it would be important. What kind of nexuses will be there in future? How the social dynamics, because he is a historian, Yuval Noah Harari is a historian, so he is primarily concerned about the society, the changes which would influence the culture, the way of doing, and the challenges. And maybe we may